these guys, the individual way shows up depending on what you happen to be talking about. All right, so let me talk about an infinite set of numbers. Here's what I'm going to do. I'm simply going to describe all the numbers that I'm talking about. And I'll bet 99% of you will understand exactly what numbers I'm talking about. I'm talking about all numbers greater than 5. Everybody okay with that? Everybody understand the description of the numbers I'm talking about? Anything greater than 5. We're going to use these three methods to notate or visually display ways to talk about anything greater than 5. Let me ask you a question. Is 6 in that set? Yes. How about 14? Yes. Now listen carefully. How about 5?
No.
No. Words mean things, ladies and gentlemen, and greater than means not included. Okay? So if I'm talking about greater than 5, 5 is not greater than 5. So 5 is not in the set. Anything greater than 5 will be. So we're going to talk about anything greater than 5. The first way we're going to indicate that set is what's called the Statement of Inequality. And we will use something that you've probably used before called set builder notation. And it starts out like this. The set of all x such that. You familiar with that? Seen that display before? That little line is read such that. In other words, it's not just any x we're talking about. It's the x is such that, and now I'm going to describe what x's we're talking about. Well, this is called the Statement of Inequality for good reason, because it uses one of the inequality symbols. You guys are familiar with the inequality symbols. They look like that, or that, right? Familiar with these guys? By the way, how do you read this? Greater than. Everything's greater than. You're correct. It's greater. That means this must be
less than.
And when we talk about the inequality symbols, you're familiar with the relationship between values when you use an inequality symbol, right? For instance, 5 is greater than 1. That's a true statement, right? And notice that the arrow always points to the
right.
Not to the right necessarily, but to the smaller number. Okay? So the arrow of inequality always points toward the smaller number. How many of you are familiar with that? Okay, time for confession. Confession is good for the soul, ladies and gentlemen. How many use the crocodile analogy? The crocodile is hungry and he's eating the larger number, okay? It's all right. It helps us to remember. The crocodile is hungry and he's eating the larger number. All right. So that's one way you can remember. The larger number is on the larger side of the inequality symbol. Another way you can use another analogy is the schoolyard bully analogy. That the big guy always points at the little guy. Okay, that's for my tragic past, but it helps me remember. It helps me remember that the larger number is pointing at the small number. Hey, that's pretty obvious. 5 is greater than 1. But this is helpful when I don't know what these values are. I don't know what A is. I don't know what B is. But I know a relationship between them. I know that A is greater than B. Let me ask you a question about that, ladies and gentlemen. If B goes right there, and A is greater than B, where does A have to go? On the right? Okay. Now let me ask a question, and just show of hands. True or false? Oh, yes or no? Raise your hand or not. I don't know. Okay. True or false? A and B are positive numbers. If you think that's true, raise your hand. A and B are positive numbers. True or false? A and B are negative numbers. I think that's true. A is positive, B is negative. Everybody think that's true? You guys are certainly non-committal today. Well, why isn't any of that stuff true? Anybody want to talk about this?
I mean, you don't know where 0 is.
You don't know where 0, the point of reference, is. So I don't know what these guys are. If 0's right here, they're both positive. If 0's over here, they're both
negative.
If 0's right there,
One's positive. One's negative.
One's positive. Absolutely. So the location of your reference point, 0, will let you know. But even without knowing where 0 is, I still know that A is greater than B because A is to the right of B. Or I could say B is less than A because B is to the left. Okay. So that's a true statement I can make even if I don't know the nature of those numbers themselves. All right. Statement of inequality. The set of all x such that, now I've already told you what numbers we're talking about, anything greater than 5. So we're just going to write there. The set of all x such that x is greater than 5. Finish. That's it. That's the inequality, this set builder notation, representation of the set, infinite set, anything greater than 5. By the way, you said 6 was in that set. You said 14 was in that set. Is 6.5 in that set?
Yes.
No.
It's greater than 5, so it's in the set. Okay. Notice I didn't specify whole numbers or positive integers greater than 5. No. Anything greater than x is greater than 5. And 6.5 is greater than 5. It's in the set. That's one way to do it. Statement of inequality. The second is a visual picture of that same concept. Now you understand each of these three methods is talking about the same set. So this next guy involves our friend, the number line. Now what values do you think I want to mark, value or values do you think I want to mark on that number line? 0. 5. Yeah. It's stuff greater than 5, right? We better show it 5. And 0, just as a point of reference. It's not required, but it reminds us that 5 is to the right of 0. Now I'm talking about everything greater than. Is that to the right or to the left of 5?
To the right.
It's to the right, so I just shade it all in. Ladies and gentlemen, be bold about your number lines. I have some very shy number line people. Like if they wanted to indicate everything greater than 5, they'd go like, so that no matter what the answer is, I think I marked it. Hey, be bold. Be courageous. It's everything to the right of 5. Now here's where we have a digression of thought and experience. Some of you guys were raised on open circles and closed circles. Let's see those open circle, closed circle hands. All right. Some of you were raised on parentheses and brackets. Let's see those hands. Not quite as many, but bad news for you open circle, closed circle people.
Shit.
This book, your web assigned homework, deals with parentheses and brackets. Okay. So if you don't know the relationship, open circle is the same as parentheses, which means do not include. Closed circle is the same as bracket, which means do include. And we're talking about every x, every value greater than 5. Do I want to include 5?
No.
So I will use the
Parentheses.
parentheses. Think y'all can handle that relationship? Changing your open circle thinking to parentheses? It's kind of a closed community, the open circle, closed circle community. I mean, they can be kind of cliquish.